Okay, sorry. Alright, so looked at interpreting and compiling programs. Let's go to the next one here. The way an interpreter works is it just takes the English high-level commands, converts it to zeros and ones, and executes it. So, and it's got to do that every single time. Whereas with the compiler compiles it into a new file with the machine code, and then it executes it. Then it's a one-time translation that can be executed each time. Operating system. It's the thing that runs your computer. I'm sure most of you are familiar with operating systems like Windows and the Mac, probably even Linux. There are others, of course, as well. Unix, I mentioned earlier. And then applications like the web browser or word processor or Excel or something like that would be applications. So that's the operating system, which controls the hardware and then also runs or executes applications. So why Java? Well, there's a lot of different languages out there. Java is definitely one of the most popular ones. It enables users to develop and deploy applications on the internet for servers, desktop computers, small handheld devices. It's used for a lot of different things other than just web. It's used, different handheld devices. Most smartphones, except for the iPhone, of course, will execute Java. It's used very popular for the internet. It's a general purpose language. You can program robots with it. You can program just about anything with it. So there are other languages that might be better and easier for web programming, like PHP. But web programming is pretty much all PHP does. It stands for Personal Home Page. And it just assumes that it's a web programming language and that's it. Whereas Java can be done for a lot of things. We use Java at the hospital for all kinds of stuff, not just web stuff. So, and it's becoming more and more popular because of the different types of devices you can carry around and embedded devices. Java is definitely becoming the language of choice for all that stuff. Java Web and Beyond. So you can use Java to build web applications, and we do that a lot where we're at work. Hopefully towards the end of the semester we'll be able to look at some Java web applications. Java applets, which is the original purpose that they started out using Java for, was as applets, and then Microsoft played all kinds of games with them. I don't know how many people are familiar with the browser wars of the late 90s. So applets didn't really work well on IE, which by then had become the #1 browser. So they went to, and applets are Java programs that run inside of a browser on the actual client computer. Java web applications, on the other hand, is Java running on the server, which is usually Unix or Linux, and executing stuff and sending the results to the browser. So it's a different mode, and we'll see throughout the semester how those two different ways work. We'll see examples of both. Java can also be used to develop applications for handheld devices, such as Palm and Cell, and all kinds of things, all sort of embedded devices. Like I said, your Blu-ray TV, if you look on the back, you're probably going to see a Java icon there. Your TV, even your automobile has got JVMs built into it. They've all got it, and pretty soon your house is going to have them. Here's a little program, and I don't know if we can bring this one up or not. Let me see if I can bring this up or not. Yes. Okay, here it is. This is a Java applet, and you'll see how this works. And we're actually going to write this Java applet by the end of the semester. Now, this is a Java applet that plays tic-tac-toe, and we're actually going to build our own version by the end of the semester. And it seems difficult, but we'll learn how to do it. And that is a Java applet. PDA and cell phones, a lot of times what you get is something called an emulator. So if you want to write a Java program to run on a PDA or a cell phone application, generally what you get, from the phone maker is an emulation tool, and this is an example of one that you use, and you can test it on your PC and then upload it to the PDA or cell phone when it's ready for the final testing before you release it to your customers. So that's an example of an emulator. Java's history. Java was created before 1995, but I think it maybe was only released in 1995. I remember going to a seminar on Java, and it was probably around that time in 1995. I think Java had unofficially been around a couple of years prior to that, but that's when 95, 96 is about when I first learned about it. I went to one of their early seminars. Hot Java was the first Java-enabled web browser. It was written completely in Java. And here's a link. You could probably go to this link and go to it, and it should show you the history. Which, of course, now goes to Oracle's website. And we'll give you all the history that you want to see about Java. Anything you ever wanted to know about Java, but were afraid to ask? Yeah. So, you can go to that website and take a look at it. So Java is simple. I don't know how simple I'd call it. It's similar to C++. That's not that simple. It's object-oriented. It's definitely object-oriented. Distributed. It's definitely distributed. Here it says Java is interpreted. And this is kind of a little bit of debate here, because Java is compiled into something what we call bytecode, which is not truly executable because it's got to be able to run on any operating system without recompiling. So in order to run the bytecode, you need something called the Java runtime environment. It's not truly interpreted or truly compiled because it's partly compiled, which means it can be executed faster than interpreted, but it's also a little slower than a truly compiled program. Although there are different programs out there called Java Hot Start or Web Start or something like that we'll look at. Essentially, and there's also something called a JITC or just-in-time compiler that the runtime will essentially recompile it to optimize it for your computer. So the first time you run it, it's a little slow, but then every time you run it after that, it's essentially native speed. Robust, yes, it definitely is. Nowadays it is. Secure, Java has something called a sandbox, but it's really only as secure as the programmer who writes it. Architecture neutral, yes. Portable, yes. Performance, it's definitely fast. Multi-threaded, yes. Multi-threaded means that it can do multiple things at once. It can do what we call running multiple threads at once. Dynamic, it's very dynamic. I don't think Java is all that simple, actually, to be honest with you, but it is a great language for it's very dynamic. You can run it anywhere. It can do almost anything. It can run on almost anything. It's truly great language, and there's so many libraries out for it that you can do just about anything in Java, really. I'm at the point where it's my preferred language for sure. Okay, I see we got some questions. Let me see what we got here. What are the differences between Java and C++ programming? Well, Java is loosely based on C++, but it's so the syntax is very similar. But C++ creates what's called as a truly compiled language, and although Java uses syntax very similar to C++, which a lot of people know, that's the difference is really it's almost like a mask. It's almost like saying that someone is your twin brother because they're wearing a mask of you. They're not really. Maybe if it's a really good mask, they actually can pass for your twin brother, but they're not really. So Java was written based on C++ syntax mainly because C++ was so widely used that everyone knew it, and they didn't have to relearn the language. So we would say that Java syntax is based on C++, but that's where the differences. After that, there's really no similarity. Internally, C++ has compilers and Java has a runtime. They are both object-oriented, though. So both Java and C++ are object-oriented. Java is what's known as a true object-oriented language. And the reason for this is because Java, unlike C++, does not maintain any downward compatibility to C. So it's true object-oriented. A C++ compiler can always compile a C program, and because they're fully compatible. We'll get into what makes an object-oriented language an object-oriented language. I mean, there's some OOP stuff you learn, and we'll get into that. And there's foundations for it. Some of the terms you're going to hear are like encapsulation, inheritance, and polymorphism, reusability, flexibility, modularity. We'll see examples of all that as we go on. Distributed. It works on a network. It can work across multiple processors. It can multitask. So it's very, very good language that way. Interpreted, as I said, you need the Java runtime to run it. So it's the bytecode, which is machine independent and can run on any machine. So bytecode is sort of a step before truly compiled, because they want Java programs to be able to run without recompilation. So as long as you have the Java runtime, it'll work. It's robust, very robust. It can multitask. It eliminates certain types of errors. There's a runtime exception handling feature to provide programming support. Again, this is all very similar to what you'd see in C++ as well. Secure. It implements security mechanisms to protect your system against harm being caused by stray programs. So it can be restricted to only run in a sandbox, what they call a sandbox, which is simply a folder or directory where it's allowed to run. It's architecture neutral. Yes, you write once and you run it anywhere. With the Java virtual machine, as long as the operating system has a Java virtual machine, it'll work on that computer. Portable, same thing basically. You can compile it on one computer, like a Mac, and run it on Windows. No recompilation necessary at all. And because it's architecture neutral, Java programs are portable. They can be run on platform without being recompiled. There's also performance things too. Java has something called a just-in-time compiler that allows it to really be optimized to the particular computer it's running on. So it's a little slow the first time it executes, then very fast after that. Multi-threading programming. So again, most of you beginning to programmers probably don't know what that is, but it's a way of doing multiple things simultaneously. I don't know if we'll get into multi-threading very much. That's more of an advanced topic, but we'll see. You might be able to. So it's designed to adapt to an ever-changing environment, and that it does that by its ability to incorporate libraries, third-party libraries from wherever. And object-oriented naturally lends itself to extending itself with new capabilities. And we'll see that again as we go on. Any questions so far?